Hello everyone, welcome back to my channel. So as a part of UGC NET Fast Track series, so in this video we are going to learn about basics of waveguides. Basics of waveguides. Okay, so this is the concept which we are going to learn. Okay, if you are first time to my channel, please consider subscribing and don't forget to hit the bell icon to get video notifications from my channel. Right, so what is waveguide? So generally EM waves are going to be transmitted from one place to another place in two modes. One is guided propagation. Okay, so guided propagation, and second is unguided propagation. Guided propagation and unguided propagation. Okay, so again in guided propagation there are two types of guided propagation phenomenon. One is transmission line, second is waveguide. And in unguided propagation we will use antennas. So for guided propagation we'll use either transmission line or waveguide. So for that we need to learn what are the differences between transmission line and waveguide, because both are used for guiding the EM waves only, or transmitting the EM waves from one place to another place through guided phenomenon. So we need to learn the differences first. So that is the concept which we are going to learn from this video. Okay, right. So what are the important points which you have to remember for waveguides is, first point is waveguide is hollow conducting transmission line. Waveguide is hollow conducting transmission line. Second important, very important point is waveguide is used only at high frequencies. Okay, so which is greater than 3 gigahertz. So waveguide is used only at high frequencies only. And third, since it is used at only high frequencies, so waveguide acts as high pass filter. Okay, so waveguide acts as high pass filter, very important. So for competitive exams it is very important. So waveguide always acts as high pass filter because it is used only at high frequencies. Okay, so now we'll see the differences between transmission line and waveguide. Okay, differences between transmission line and waveguide. So the first difference already we have discussed. So okay, transmission line, which is also very important difference, transmission line is used at low frequencies. Transmission line is used at low frequencies, that is at radio frequency range only transmission line is going to be used. But waveguide is used at high frequency range. Okay, so it is used at high frequency range which is greater than 3 gigahertz. Okay, so if you use a transmission line at high frequencies, losses will occur. Okay, so and if you use a waveguide at low frequencies, it becomes bulky. Okay, so it becomes bulky at low frequency. So that is why low transmission line is used only at low frequencies and waveguide is used at high frequencies. This is the first difference. And second difference is transmission line consists of two conductors. So that is why two conductors are there in between. We will draw the equivalent circuit and we'll do the analysis. Okay, but waveguide consists of only one conductor. Waveguide consists of only one conductor. Okay, so the third difference is in transmission line the source elements are source elements are voltages and currents. Okay, so that is why the equation we will get dou square if the wave is propagating along z direction, so it will be gamma square into v. Similarly, if you want to write for current, dou square I by dou z square is equal to gamma square into I. So here voltages and currents are the basic elements or source elements. But in waveguide, the basic elements are electric field and magnetic field. Okay, so that is why we will get the concept of characteristic impedance in the case of transmission line, because we are dealing with voltages and currents. Okay, since we are dealing with the voltages and current, transmission line satisfies Kirchhoff laws. Okay, transmission line satisfies Kirchhoff's laws because we are dealing with voltages and currents. So waveguide deals with electric field and magnetic field, so it satisfies Maxwell's equations. This is also one of the important point. So transmission line satisfies Kirchhoff law because we are dealing with voltages and current, and waveguide, since its source elements are electric field and magnetic field, so waveguide satisfies Maxwell's equations. That is, analysis of waveguide is done by using Maxwell's equations only. Okay, so the fifth point or the fifth difference is, since we are having voltages and currents, so transmission line is analyzed in one dimensional. So the analysis is one dimensional for transmission line. Okay, so for waveguide it is three dimensional. That is, we have to take the coordinate system and do the analysis in the case of waveguide. Right, so these are the basic differences between transmission lines and waveguides, and this is why waveguides are used. Waveguides are used for propagation of EM waves from one place to another place under guided medium only. Okay, so what are the advantages? What are the advantages of waveguide over transmission line? So what are the advantages of waveguide over transmission line? The first advantage is high power handling capability. High power handling capability. So waveguide will handle more power when compared to transmission line. Second is low loss per unit length. Low loss per unit length. And the last advantage is simple in construction, because it will have only one conductor, so it is simple in construction. So when it is simple in construction and has only one conductor, it will be of low cost automatically. Okay, so this is the basic of waveguide, and this is the basic differences between waveguide and transmission line. Okay, so in the next video we'll learn about the basics of rectangular waveguide. Okay,